Hello and welcome to the second part of our discussion on systems of linear equations and their applications. In this video, we will be exploring several real-life applications of linear equations such as age problem, work problem, and the like. We will be making sense of these problems and practice on how to use given pieces of information to look for that which is missing. Let's begin with our first problem. The sum of two numbers is twice their difference. The larger number is 6 more than twice the smaller. Find the numbers. The first skill needed to solve word problems is translating English phrases into mathematical expressions. As much as possible, we would like to represent everything with a single variable. In this problem, let us represent the smaller variable with x. Also, the problem states that the larger number is 6 more than twice the smaller. Then we can write the larger number as 6 plus 2 times the smaller number. But since we represent the smaller number with x, then we write the larger number as 6 plus 2x. Now, the sum of two numbers, that is, the larger number plus the smaller number, is twice their difference. That is, 2 times the larger minus the smaller number. We write the larger number in terms of x and the smaller number in terms of x. We now have our equation with an unknown x. Simplifying, we get 6 plus 3x equals 2 times 6 plus x. Distributing 2 to 6 and x, we get 12 plus 2x. Subtracting 2x and 6 on both sides, we get 3x minus 2x equals 12 minus 6. We simplify this to get x equals 6. X then, our smaller number, is 6. We use this to solve the larger number. Substituting, we get 6 plus 2 times 6, or 6 plus 12, which is equal to 18. Therefore, the smaller number is 6 and the larger number is 18. Let's try another problem. Robert is now 78 years old and his friend Charlie is 70. How many years ago was Charlie only 3/4 as old as Robert? In these types of problem, it would be helpful if we create a table. In the first column, I will write Robert and Charlie's present age. And in the second column, their age x years ago. At present, Robert is 78 years old. This means that x years ago, he was 78 minus x years old. At present, Charlie is 70 years old. This means that x years ago, he was 70 minus x years old. The problem wants to identify how many years ago was Charlie only 3/4 as old as Robert. This means that we want to know when is it that Charlie's age, x years ago, equal to 3/4 that of Robert's x years ago. From our table, we can represent these with variable x. We have 70 minus x, Charlie's age x years ago, equals 3/4 times 78 minus x, Robert's age x years ago. We can now start solving for x. To simplify, we multiply both sides by 4. We get 280 minus 4x equals 3 times 78 minus x. Distributing 3 to 78 and negative x, we get 280 minus 4x equals 234 minus 3x. Adding 3x and subtracting 280 to both sides, we get 3x minus 4x equals 234 minus 280. Simplifying, we have negative x equals negative 46. We divide both sides by negative 1 to get x equals 46. Therefore, Charlie was only 3/4 as old as Robert 46 years ago. Let's now try another type of word problem, a work problem. One pipe can fill a tank alone in 6 hours. Another pipe can fill it alone in 9 hours. If the tank is empty and the two pipes are open, how long will it take to fill the tank? The technique is to express the given information into ratios. Since one pipe let's say pipe A, can fill a tank alone in 6 hours, then the tank-hour ratio for pipe A is 1:6. That is, one tank is to 6 hours. Another pipe can fill it alone in 9 hours. Let's call this pipe B. We assign 1:9 to pipe B, that is, one tank is filled in 9 hours. The problem is asking, if pipe A and pipe B work together, they can fill in one tank in how many hours? Remember that we can write ratios into fractions. Translating this setup into mathematical equation, I get 1/6 plus 1/9 equals 1/x. We first add 1/6 and 1/9, giving us 5/18 equals 1/x. We then multiplied both sides by 18x, and we get 5x equals 18. Dividing both sides by 5, we get x equals 18/5. Therefore, it will take the two pipes 18/5 hours to fill the tank. That's roughly 3.6 hours. Let us now have our final problem. The length of a rectangular lot is 3 times its width. If the length is increased by 5 feet and the width is decreased by 2 feet, the original area of the lot is decreased by 21 square feet. Find the length and the width. It is again helpful to create a table out of the given information. In this table, I will write the width, the length, and the area given the original dimension and the altered dimension. Originally, the length of the lot is 3 times the width. That is, if the width is x, then the length is 3x. This makes the area, which is length times width, be 3x times x. We alter these dimensions. The width is decreased by 2, so the altered width is x minus 2. And the length is increased by 5, so the altered length is 3x plus 5. This makes the altered area, length times width, 3x plus 5 times x minus 2. The problem states that when the length and width are altered, the area of the lot is decreased by 21, meaning the area after the dimension is altered, which is 3x plus 5 times x minus 2, is equal to the original area, which is 3x times x minus 21. This is now the equation that we want to work with. By distributive property, in the left side of the equation, we get 3x squared minus x minus 10. We simplify the right side to get 3x squared minus 21. We subtract 3x squared from both sides and add 10 to both sides. This gives us 3x squared minus 3x squared minus x equals negative 21 plus 10. Simplifying, we get negative x equals negative 11. Dividing both sides by negative 1, we get 11. This means that the rectangle has a width of 11 feet and a length of 3 times 11, or 33 feet.